This day is all about US-Israeli collaboration. Three organizations have joined forces and taken the initiative to make this happen.
And I'm very honored to welcome you today to this wonderful auditorium at the National Academy of Science for the conference Accelerating US-Israel Neuroscience and Neurotechnology Collaborations.
Brain-related health challenges and trauma are vicious enemies. When they strike our loved ones, our friends, and our service members, they are ruthless to their victims. Overcoming these challenges requires significant financial resources and the tireless dedication, work, and commitment of our scientific community. And it was a personal recognition and commitment to the level of resources still needed that Congressman Patrick Kennedy decided to dedicate his entire professional capacity to working on the solutions.
It's going to be you in the neuroscience community who's going to be kicking down those doors, turning on the light of opportunity, and showing those young veterans, not only in the United States, but I suspect many veterans in Israel too, that are suffering from traumatic brain injury and post-traumatic stress, that there is an answer. I'm very impressed with the turnout and the caliber of the people that you have presenting today. And I know that the purpose of this is to bring people together, get people talking, and try to begin the collaborations that are going to be helpful to advancing the science.
Autism, Alzheimer's, multiple sclerosis, depression are just some of the long list of horrendous afflictions, which we can trace back to this one organ that can look around the universe and understand the universe but cannot understand itself.
Here we're going to actually focus on the device side of neurotechnology.
Hutchinson is among the first humans to have her brain directly wired to a computer.
We're seeing Kathy moving this cursor with nothing but her mind. That's pretty amazing. And so, I mean, if Kathy can control a cursor, she can control anything a computer is connected to.
What if we could actually demonstrate that we can not only decode and allow patients to have voluntary control over, say, devices as we've done, but if we could also allow them to regain control of their own limbs, someone who's paralyzed actually achieving volitional control of a paralyzed limb. So what you're seeing is the brain data from someone else's brain controlling a second person's hand.
What our patients want is a Luke Skywalker arm, where the thing looks like an arm, but he controls it the way you and I control our arms. How do you and I control our arms? We don't think about, oh, extend your elbow, extend your wrist, open your fingers. You don't think that. You think, oh, I want to pick up that ball, and you reach out and you grab it. And the idea is that we can go ahead and use a small device, ECOG, very small. It's about the size of your pinky nail, and it lays on the surface of the brain, picks up EEG signals, and can you control an external device with just thinking about it, just thinking about it. Patient has a Christopher Reeve injury that caused a transection of his spinal cord at the cervical level, so he could not move his arms or legs at all. He has no movement of his arms or legs.
Baby, I want to hold your
hand. She wants to hold his hand.
Nice.
There you go. Think about that for a minute. That's not his hand.
Right, that's nice, Ollie.
Sitting on a stand.
Very nice.
But because the way he's controlling it, the way it's being interacted, she calls it his hand. And this, her reaction, is why all of us do what we do. That's what we're doing. Because at the end of the day, science is a great thing, but we have to serve a constituency. And those are our patients, our fellow Americans, our fellow Israelis. And really, I believe that what you're seeing here is an extraordinary opening of what neuroscience can do.
And biology today is a hardcore science. We want to find whether something functions or not. We make a mouse. And I'd like to tell you about a new family of genes that I believe, and many others do too, are a focus of hope for the next generation diagnosis and treatment of many ailments, including post-traumatic stress. These are microRNAs.
Research, as we've heard this morning, can clearly reduce some of the suffering. Unfortunately, the challenges that we face, for the most part, some of it has a lot to do with the fact that most of the research, due to funding, is at most of it is disciplinary, and what we need is multidisciplinary research.
I see a great future in the cooperation in neuroscience between the two countries, and really to the benefit of both the US and Israel.
What we see is that Israel concentrates their efforts mainly in neurology. As you see, 23% of the effort in drug discovery in Israel today is in the neurology area.